All right, what we're going to be looking at today are points, lines, and planes. And this is section 1, 2 in the geometry textbook. And the first thing we want to talk about is the point. And a point is an exact location in space. It actually has 0 dimensions, which means if you were to have an actual point, it wouldn't be visible. And it's named with a capital letter. Now, to represent a point, we would use a dot, just like that. And they would always have some sort of letter associated with them. And this right here would be called point B. So that's the point. The line. A line is a string of points continuing indefinitely in a straight path in both directions. It's one-dimensional in that the only dimension it has is length. And it's named with either a lowercase letter or 2 capital letters, which would be 2 points on the line. So any line goes infinitely in both directions, and that's what these arrows represent. They say that we're going infinitely in that direction. Oops, let me bring that back. Okay, those arrows say we're going infinitely in this direction, and this direction. Now, as far as naming them, with the line here, if we draw one here, sometimes they'll have a lowercase letter down here, so that'll mean this is line Q. Okay, but if there's points on here, there's several names you could give this line right now. Any 2 points can be used, so we could say WO or CW or OC, all describing the same line. And so here are several names that you could give. And as you notice, when looking at these names, we put an actual line above the 2 letters to signify that we're talking about a line that goes infinitely in both directions. Okay, because there's going to be a big difference when we have this shape up here, this line, compared to when we don't. Okay, and we call line Q. Now the plane. I think everyone knows what a plane looks like. Now, of course, that's not the kind of plane we're talking about. A plane is a flat surface that of points that extends out infinitely in all directions. It's two-dimensional. It has length and width. And it's named with a capital letter or 3 non-collinear points on the plane. So here we have a plane, and if I wanted to name this plane, I could use 3 non-collinear points. And we'll talk about non-collinear means when they don't line up in a line. So I could call this plane ELF or FEL. Also, sometimes we'll have a big fancy letter in the corner of the plane. Now this parallelogram, this rectangle-ish, it looks like it's given it 3 dimensions here, kind of making it look like it's going backwards. It looks like it's in the corner. Now, a plane we know goes off infinitely, but we use this to represent the plane. And this big fancy letter can be naming the plane, so this is plane M. It's usually italicized or in some other fashion to make it clear that it's not a point that we're talking about. So, and these are different names that we could give to this plane. Collinear and coplanar are just what they sound like. Collinear, sharing a line, so they lie on the same line, or could lie on the same line. And coplanar, just what it sounds like, is capable of lying in the same plane. Now, the key here is that the line or plane does not actually have to be shown. meaning I could just draw any 2 points in space and say, are those 2 points collinear? Well, could I draw a line right through them? Yes. Are these 3 points collinear? Yes. Now, are these 4 points collinear? No, I can't draw one line that goes through all 4. Right, now the intersection of 2 figures. If we have 2 lines that intersect, looks here like they intersect in a point. If 2 planes intersect, their intersection is a line. And if a line intersects a plane, it just intersects it at a single point, which is taking a little longer to get out here. Okay. So here's a little question section for you. Are these points coplanar? Look at points C, D, and H. I'll label them here. There's C, D, and H. And we ask, are they coplanar? Well, we can actually see that they lie in the same plane, so that's a yes. Okay. How about A, C, E, H? A, C, E, and H. Are they coplanar? Well, the question is, could they lie on the same plane? Well, if you look at this like a block of cheese, ask yourself, could I make one chop with a butcher knife, a straight chop that would go through all 4 points? And it actually would look something like that. Goes right through the side, right through the diagonal there. So yes, they are coplanar. Now the next part says, are G, F, and C? G, F, and C. Could I make one cut with a butcher knife to go through all 3 of those? The answer here is, let's take a look. I did my best to draw it here. The answer here is yes, they can. We'll find out later that any 3 points will be coplanar. There's a great video you can view. Here's a link to it. It's called Things That Don't Exist. It'll be a fun little way to give you an idea of how we think about geometry in the first couple minutes. The rest of it's mostly just for fun.